This is an impedance simplification problem. So we've got resistor, cap, resistor, inductor, resistor. We've got on this other branch over here, we've got a resistor, cap, an inductor, and there's nodes A and B here. And what we're asked to find on this problem is the impedance between nodes A and B. So the total impedance seen from, the left, seen from nodes A and B. One ohm minus J8. So this is already in frequency domain. This cap is minus J8. So there's some capacitance value and some frequency that works out to minus J8. We don't need to know those values for this particular problem. This one's J4 is 40 ohms, 10 ohms, minus J20 ohms, J20 ohms. Okay, so just a quick check. The resistors are straight real numbers, 10 to 41. The inductors are positive imaginary numbers, or positive, imaginary, completely imaginary. They have no real component. And the capacitors are negative J's. All right, and let's see, let's throw some more nodes on here. It's node B, node C. So this is also node C. Oops, no, this is node A. Yeah, no, that's correct. It's a new node B, because from A there's some elements in between here and here, so that would be a new node. But here there's no elements across here, so B is across both of those. Okay, here's what's in parallel and what's in series, right? These two guys are in series. What about all this stuff? Well, like the 2 and the J4, those are in series with each other, right? And the 10 and the minus J20, those are in series with each other. But this branch here and this branch here are in parallel with each other. Likewise, these two elements are in parallel with each other. So some students have trouble with this kind of stuff. So if you do, it might be helpful to label the nodes and then take the time to redraw it. So that it's explicit what's going on here. Because what's happening really is we've got B comes down and then it splits into this guy and this guy, and then they come together at C, right? Then they split up again, and then they come back together at B, and you got out this way. Oh, I got two B's here. Oh shoot. Let's call this, it's like a B at the bottom. Now, does it matter? Let's see, let's call this capital B. Okay, yeah, all right, so this I could even relabel these guys just to be clear, just to be more abundantly clear. All right, so these two are in parallel with each other. These two in series, and then this whole branch is in parallel with this whole branch, and then these elements are in series. So what's the equation, right? It's going to be ZAB, and I can write it all out kind of all at once, sort of. It's not that hard. I've got the 1 minus J8. That's these two guys, right? Then I've got the 2 and J4 branch, this thing, which are in parallel with the 10 and minus J20 branch, right? Then this set of guys here are in series with this set, these two guys, right? So then I've got a 40 in parallel with the J20. Okay, so this is 1 minus J8 plus, and our formula for parallel elements in impedance is just like resistance. Okay, it's going to be the product over the sum. So 2 plus J4 times 10 minus J20 over the sum of those two guys, 2 plus J4 plus 10 minus J20 plus, using our parallel simplification formula, it's the product over the sum. Okay, then get your calculator and punch in all of these complex numbers and, you know, multiply these two and add these two and divide, and then you're going to get, just to be clear, 1 plus J8 plus this whole thing here becomes 3 plus J4, and this whole thing here becomes 8 plus J16 on your calculator. So this guy ends up being, the total thing is 12 plus 12J. These are both 12, so that's going to be a 45 angle. And if you hit the polar to rectangular conversion button on your calculator, which you should have, it's going to be 16.97 angle 45 degrees. That's the answer in rectangular and in polar. Okay, nice little problem.